All right, so number one, we start out with a few definitions. So we're asked to fill in the blank. So suppose we got a simple random sample, size n, drawn from a large population. Mean is mu, standard deviation is sigma. The sampling distribution, x bar, has a mean of blank, and the standard deviation has a standard deviation sigma of blank. So the mean is going to be equal to the population mean. That's what we got from this section. And the standard deviation is going to be equal to the population standard deviation divided by the square root of n. So this is just kind of filling in the definition. All right, question 2 is the statement below true or false. So the distribution of the sample mean x bar will be normally distributed if the sample is obtained from a population that is normally distributed regardless of the sample size. So yes, if we pick a sample from a distribution that's already normal, okay, the mean, the sample mean will also be normal, and it doesn't matter about the sample size. All right, question number 3. So we have a simple random sample of size 56, so that's my sample size, obtained from a population that is skewed to the left. The mean is 71, and the sigma, standard deviation, is 3. Does the population need to be normally distributed for the sample distribution of x bar to be approximately normal? Why? And what is the sampling distribution of x bar? Okay, so we are told that this comes from a distribution that is skewed to the left. However, the sampling distribution will be approximately normal if your sample size is greater than or equal to 30. That's what we talked about in the reading. So since we have a sample size of 56, we can approximate normal distribution. So it says, does the population need to be normally distributed? No, in this case, because our sample size is 30 or greater. So we're going to say no. The central limit states that regardless of the shape of the underlying population, the sampling distribution of x bar becomes approximately normal as the sample size n increases. And yes, that's the case. So we do not have to be normal as long as our sample size is big enough. So B is going to be our best choice here. And then part 2, what is the sampling distribution of x bar? So the sampling distribution of x bar of the sample distribution is going to be approximately normal. So we're going to say the shape of the distribution skewed left, it says unknown. This is approximately normal. Okay, it's going to be approximately normal. The mean is going to be, and we say as we want to round to 3 decimal places. Okay, so the mean is going to be equal to the mean of the distribution, which is going to be 71. So that's part of the formula. The standard deviation is going to be equal to the sigma divided by square root of n. So I'm going to have to use my calculator here. So I'm going to turn this on. Sigma, which is 3, we're going to divide that by the square root of n, our sample size, which is 56. And we want to round to 3 decimal places, so 0.400, and then the 8 will round it up, so 0.401.